Again, my name is Dan Spiker. I'm going to help with some of the conversations over the course of the next 2 hours. We're going to begin with Dave and Ken giving us a summation.
Well, Happy New Year, folks. Glad to see you back. A lot of familiar faces, and so we're glad to be joining you again here this year to start getting into some of the details of our project. So before I jump into kind of an overview, I wanted to take just a minute, one, to say thank you, and two, to introduce our team, the Water Bureau team, folks that are here tonight. Then Dan will get into the introductions of the audience and our committee members and new members. There are several new faces here tonight, so we appreciate you coming out and participating with us, and hope you'll have some good input for us tonight as we go through the evening. So I'm David Peters. I'm the program director for the Portland Water Bureau for the Bull Run filtration improvements. With me from the Water Bureau tonight, I have Ken Ackerman, who's one of our project managers and will be working on our pipelines. And we have Benita Oswald, who's our public information officer on our project. We also have some of our consulting team here with us. Dan Spiker, who you just met, is our facilitator for the evening. We have Jude Grounds and Jeff McGraw and Mark Graham, who are all part of our design team. And then we have Libby, Baki, and Aubrey. She must be out in the foyer, helping with the logistics and the setup of the meeting. And we have Sam Boruski back here on the camera. So he is creating a video of tonight's proceedings, and that will be going up on our website after the meeting, as the videos from the other meetings have done. So that's our project team. What I'd like to do is take a couple minutes. We had a busy end of the year. We met with you in October and kind of got this group set up. Had a couple conversations that were more introductory in nature. In November, we had the opportunity to go out and visit a treatment plant, and so a number of you went out to visit that, and we'll have an opportunity to talk about that visit. And then we'll get into what it takes to put a design together for a treatment plant. But at the end of the year, our city council did take a couple actions, and I want to take just a minute to talk about those. If we could have the first slide. So what we have here is just a timeline of this project. It started in 2017 when we started seeing cryptosporidium hits in our Bull Run watershed. And that's led up to two council actions that our city council took in November, right before Thanksgiving. And many of you were there to testify and comment on those actions. And those two actions were, one, a resolution that outlined a set of values and priorities that our city council directed us as the Water Bureau to take into account as we move this project forward, and I'll talk about those in just a moment. And the second action was an ordinance that authorized a design contract with the design firms who we have representatives of here tonight. So from this point on, we'll actually be able to start thinking about what it takes to design this facility. And we have those designers here to talk about that process and to begin to get your input into that process. Next slide. So leading with values, these are the values and priorities that the city council gave us. First priority that we need to meet the regulations that the EPA set are water quality regulations. So we want to ensure that we have safe drinking water into the future. Resilience, we want to be sure that we're creating a system that is going to be here when we need it, when there's an earthquake or a forest fire or turbidity events in the Bull Run. Filtration plant will allow us to meet those goals. Keeping in mind cost and value is important, and the community environment And so that last one, the community environment, is why we're here talking with you. We'd like to get your thoughts and input into this process as we go forward. So you may be aware of a number of the current activities on the filtration. As we've been out talking to a number of you, been in many homes talking about these activities, getting out doing geotechnical investigations, which are part of our evaluations and studies. We're doing the outreach. We've created this process to have your thoughts and input into our design, and we're getting ready to start our preliminary design. So those are all topics that have been started over the past year, and now we have the opportunity to get into the actual design. And that's the process now that we have the design contract under our belt, that we'll be able to begin to talk to you earnestly about what it is we need to do and get your input on what that might look like. So at this point, how will it make it more? Mm-hmm. Sure. Sure. What we've been doing to prepare for an earthquake is creating a backbone. And so by putting these facilities, the pipelines and the treatment plant will be built to seismic standards that will withstand the major earthquake, and gives us a section of our system that will be able to withstand that. And our goal is, in the long run, to meet the goals of the Oregon Resilience Plan, is to have water back in that backbone within 24 hours of a major event. So these systems will be built to be able to provide that. So at this point, what I'd like to do is introduce Ken Ackerman again, and he's going to talk a little bit about, you recently got a flyer talking about investigations we need to do to begin thinking about pipeline alignments, and he's going to talk a little bit about that.
So I've been on the project for just several months, I'm going to be leading the pipeline design. We do not have our designers on board yet. We are still evaluating alternatives. We'll be doing that this spring, trying to finalize our alignment alternatives, and that's what we're going to be out here doing. We're actually going to have surveyors out in the next probably month and a half or so, doing some physical surveying. We've done some. We're going to be continuing that. We're going to be talking to some property owners about getting on their property to look at those properties and just to evaluate those. And we'll be making arrangements with individual property owners. So we're in that alternative analysis phase. We're looking at different routes. So that's what these areas are for. We now know we're building 2 pipes in, 2 pipes out with the city council resolution. And we'll be getting our designer on board this spring, probably starting our design this fall and going through our final design, and then starting construction about the same time we start construction on the treatment plant. So I'm here tonight just to meet people, get to know people, and hear concerns. We're going to be out doing a lot of work, so just here to get information. So was there one more slide? Yeah, this is the same map that was in the flyer, just the areas where we're going to be looking. We'll be looking in the roads. We're going to start the survey work in the road right away. So on Dodge Park and then Altman Road. So I think that's, is there one more slide? Nope, okay. So.
Any of your pipeline alternatives involve property you don't have easements currently? You've got several alternatives you're looking at. Do any of them go through land that you don't have an easement?
Potentially, yes. So
I'm sure you've already connected with people that could be affected by, or affected, no, 20 is less, affected by that. You've already talked with those people?
no, not all of them.
Why not?
We're still evaluating alternatives at this point. So we have not made any final decisions on where pipe are going. So I mean, we're trying to figure out what the best route for those pipes are.
It's not exactly part of the process then, is it? I mean, you're not making the people part of the process,
Yeah.
just hearing them what you're going to do.
No, we're here tonight to hear people's concerns, and we're going to be out. We will be doing this for several more months before we make any final decisions on where pipe routes go. So.
And part of this flyer went out with the idea that this is the group we want to connect with. And so folks will be coming out and meeting with those individuals and talking to them,
And
getting more information.
we will be scheduling meetings with people to talk to them about getting on their property individually. Benita and I will be out talking to property owners. So nothing is set at this point.
So how is this billion-dollar treatment center going to protect all these pipes during an earthquake? Isn't that what you're saying, that there's protection during an earthquake?
For the pipe portion of this, our pipes that we are currently using are 80, they're old.
110 is the oldest.
The new pipes will be designed, those pipes were designed, we didn't know that there was going to be a major earthquake. That wasn't known in the last 100 years ago. The new pipes that we put in will be designed to withstand an earthquake. Yes, they will be designed to the Cascadia earthquake standards.
And how does that replace the pipes between Headworks and the Hudson?
It doesn't, but we got to start somewhere, and this is a piece of the segment of the system that we can replace, and it's one piece. So,
Right, but according to the 2017 seismic study that Portland commissioned, those pipes between the Hudson Intertide to 162nd are the ones rated a very low risk, while the pipes that go under the Willamette and the pipes from the Hudson, from Headworks to Hudson are, according to that report, 100% good risk.
So, I'm sorry. So, yes, we do have studies that talk about all that, and there is higher risk as you go up the canyon, into the Bull Run, into the watershed. We have been working on those pipelines over the last 30, 40 years, and there are major sections that have been enhanced up through that area. We did tunnels under the Sandy River in 2013, I think it was. We've done all the bridge crossings in the watershed. We have plans to go in and reinforce the pieces of pipe that are there. So we have been working on that for 30 or 40 years, and there are major portions of that upper section that are done. This is another section that gets done as part of that enhances that system for an earthquake. Yeah. Well, it does say things will break, and they will. The goal is to minimize the number of breaks that you're going to have during that earthquake, because it is tough to make it 100% resilient to everything that comes along.
Absolutely, but the report actually says that the pipes under the Willamette River are like, there's an 87% probability that all 5 pipes under the Willamette.
So we have a project going on right now where we're installing a new seismically resilient pipe underneath the Willamette River. One pipe that has the capacity of 3 or 4 of those. Yes.
I think the point of it is that you're laying out rationale for the facility, like the pipes may be in need of some repair or reinforcement, but you guys are claiming the facility itself, the filtration plant, is going to do something if there's a large earthquake. And I'm suggesting to you that's you're selling the project on the basis of these big natural disasters that just don't see how this filtration plant is going to protect your system in the event of an earthquake. It doesn't make any sense to me.
So the goal is to have water. That's why we're reinforcing the pipelines. The treatment plant helps us in these situations where it's the other effects of the earthquake. It's the landslides. It's the land movement. It's the turbidity that shows up in our watershed after these events that the treatment plant helps us with. So we've used the forest fire example. Forest fire, after forest fire, you get a rain event, you get high turbidity, you get a lot of organics into your water. In those situations, we would have to shut down the bull run system and run off the groundwater system if we don't have a filtration plant. And so the filtration is helping us in those situations. It's in the case of seismic, it's the alternate effects of things that might happen. Well, and that's the regulatory issue.
Earthquakes and landslides and catastrophic fires, and it's grown right along with the budget.
So as we've had conversations with our city council, the risk, you comment about how the risk of cryptosporidium is low. The risk we have, it is.
But if it is because the feds say so, then deal with that. But let's not go for large catastrophic fires and big natural disasters and scare everybody into a billion-dollar project.
Those are higher risks to our watershed than cryptosporidium. And that's why we're trying to address those issues. We have had to shut the bull run system down for turbidity events. We did that several times through the 90s. We had the risk of the forest fire that nearly came into our watershed just 2 years ago. Those are things we worry about that keep us awake at night that will be resolved by the filtration plant.
Dave, I have a suggestion.
Sure.
We do have a lot of topics to cover over the course of the next hour and a half. One of the things we like to do is introduce this team, this group, to some new information. I'm not sure if it'll answer your questions, but my hope is that it is going to answer some additional questions. So what if we keep going with our agenda, get some reactions from you? There is certainly a public comment period, and we'll do our best to answer those questions throughout the course of our conversation. We've done a few different things here. Thank you, Dave. We've done a few different things here over the course of the last few months. Our format's a little bit different, not just in the seating arrangement, but also, as Dave indicated, we're asking a number of the design consultants to come and help be part of this official committee. So we have Mark and Jeff and Jude. You met Jude back in October when he gave some material associated with the design, but you have not met Mark or Jeff. So Mark, could you give 30 seconds on who you are and what your particular role is on this project?
Sure. My name is Mark Graham. Turns me up. I'm a project manager and engineer with the design team. I'm leading the design team. I have worked on a number of large water treatment plants throughout the U.S. Most recently, I was the project manager, deputy project manager during design and project manager during construction of the Green River filtration facility up for Tacoma, which was dealing with a very similar situation in compliance and moving an unfiltered to a filtered water system. And I'm really excited to share that experience and other experience on treatment plant project development with the Portland Water Bureau and this community.
Great, thank you. And Jeff?
I'm Jeff McGraw. I'm an architect, and I work out of Portland. This is our 32nd year of working with... Does it work? Good. Yeah, thank you. About 40% of our work is housing, affordable housing, things like that. About 60% of our work is all infrastructure and transportation projects. We've been in the water industry for quite some time. Have just finished a project up in Whidbey Island you might look at called Oak Harbor. That is on our website. But we specialize in these kind of facilities, and we are very much mainstream architects doing convention centers, airports, those sorts of things as well. So we're very fortunate to be involved in this project because I don't have to get on a plane, and I'm looking forward to working with all of you. So thank you.
Great, thank you, Jeff. So one of the things that this stakeholder advisory group requested is to have more information more readily. So the reason these gentlemen are here as part of the conversation, we'll be able to provide more information more quickly, and of course then you provide more information to them that they can instill in their own heads and take away from these conversations. So that's the reason why they've been invited to these conversations. The third thing is we actually do have a new member, and I'm going to ask Sarah to introduce herself very quickly.
I don't need a microphone. I'm loud enough. I am a local resident of more than 40 years. I do know this project inside out, and I have most of my neighbors over there with whom I agree. And my purpose is to hope that you, the Portland Water Bureau, do open up the conversation and the interchange of ideas more than the one-way conversation that has happened. I have already written to Jeff McGraw back in June after he was thrown under the bus at a earlier meeting of the Portland Water Bureau, and I am well versed on Bull Run and the city of Portland, and I have roots going back shortly after the Civil War when this city was built and financed. So I will be pleasantly surprised if the corporate culture of the Portland Water Bureau softens. That's the best way I can put it.
Great. Appreciate it, Sarah. I'm glad you're here. All right. With that, I'm going to have Jude help me with this next conversation, and that is who on the Stakeholder Advisory Group went to the facility tours? Okay, so 1, 2, 3 of you. Okay, so I don't know if you've seen these photos as of yet, but you may have. But maybe it was obvious, maybe it was just a little covert action here, but there is a very short video of some of you walking around that facility during, this happened in November, is that right, Jude? Okay. And a number of you were there. Some people that are not currently with us tonight were also part of this conversation and introduction. So what I'm curious about is, as you refresh your memory about being there, it looked like a glorious day in November, what came to mind? What were some of the impressions that you had leaving that conversation? Charlie, let's start with you. What was some of your reaction to this? Anybody is fine. You can sit, you can stand, whatever you feel comfortable with.
So going on this tour, I know it answered a lot of my concerns and questions. It was really nice because I haven't been to a water treatment plant. I don't know how many of us have or haven't. But overall, I know a lot of concerns had to do with light and sound and waste and chemicals. And they gave us access to where they stored the chemicals and what waste was being produced, which was like dirt and other things like that, and gave us a firsthand experience of what it did sound like and what it looked like. And overall, it was a beautiful facility.
Great. Pat, same thing. Other impressions that you had relative to this?
Well, it was a beautiful facility, but it was a little over 4 acres. And the facility that's going to be right behind us is going to be 40-some acres. So I'm not taking away from what a beautiful place it was with the park and everything, but our facility is going to be way larger.
Yeah, so scale is definitely going to be different, right? Okay. And Mike, you were also there too, weren't you?
Yeah.
Right.
It was nothing new for me. I spent 30 years in water reclamation plants, so I wasn't impressed. I wasn't unimpressed or nothing. I was just having bad nightmares because I never thought I'd be in one again.
Fair enough. Okay, very good. All right. Jude, how about reacting very quickly to the comment about the scale or the size of this?
The largest water treatment plant right now in Oregon is about 85 million gallons a day. So a little more than half the size of this plant. So trying to find, and the team will have an opportunity to tour that treatment back here, I think in February. So in terms of scale, I think that might be a little more comparable. This was a treatment plant that was kind of necessary. So the things that we were trying to highlight here were how to capture the neighbors' concerns and integrate that into the design so people could understand how how you all's input can influence the look and feel of this. I'd say the one thing that I remember from my first meeting with you all was that you were sick of seeing the pretty outside of this thing. You wanted to see the inside, like show us what's inside this, over the fence. And so I think that was good, and I think people generally had a good, as Charlie said, opportunity to kind of see those things. I think the look and feel of the plant that will be your neighbor can be very different than this. This was an attempt to bring people in and draw people to a park and have a water feature and public amenities that would draw people in. It doesn't sound like that's what you guys wanted to achieve through your input as part of this process, but again, just to be an example of what you can actually have an input on and an impact on in terms of the water treatment plant.
Okay, great. Let's go one step further then. So Benita, I'm going to look to you to help with this. So there is a plan, as Jude inferred, to actually have another tour, likely on the 13th of February. And that was a date, right, Benita, that this group thought would be an appropriate date to do?
Yes, that's correct. February 13th, right before Valentine's Day.
And the idea is the mechanical or logistics perspective of that is what? What's the plan for now?
Well, we wanted to get an opinion of whether you wanted to look at something that was more similar in size of what our facility will look like, or if you're interested in looking at something that would be more similar in design. So we have the Joint Water Commission treatment plant, which is in a rural area. And that's what this one looks like. It's out in Forest Grove. Is that right? A little bit further than that. Either way, we would be able to provide transportation from Sandy to go out to that area. Do we have another slide of the next facility?
I don't think we do.
Oh, okay.
No.
So the other one was in Lake Oswego. And so it's a smaller facility, but a newer facility.
Okay, good. Well, I'm going to look to the stakeholder advisory group to get some reflection upon that, to give some impressions. So the first thing I heard, Pat in particular, talked about scale. So this Joint Water Commission one could be a site that could provide a better impression of a larger facility, okay? Maybe not as big as what is maybe being proposed here, but it could give you a sense of scale, okay? What other things among this team would be curious to learn a little bit more about beyond scale? Are there other details you weren't able to necessarily learn about at the Wilsonville facility? Steve?
Actually, my name is Gerald Murphy. I'm representing Sandy River Watershed Council. Staff could not make it. I have a question on how is this going to benefit the watershed overall?
Right. Okay.
I do have an idea, too. I would like to ask. There's an ongoing problem in the city of Sandy with growth right now and keeping up with its wastewater treatment and stormwater treatment. Can this facility, since it is state-of-the-art, $1 billion facility, handle an effluent load that the city of Sandy produces?
Okay. Got it. Okay, others on the advisory committee. Any other questions that you'd like to have? Pat, please.
I'd like to have more information about that. If there are going to be settling ponds, I'd like more information about that. If they're lined with something, what are they lined with? Because we have a well, and my concern is that chemicals will be leached into the ground, into our aquifer, and so I would like more information about that.
Good. Okay. What else might help us determine? Sarah?
I'd like to know how deep we'll be digging, because a lot of us are on well water in the neighborhood, and the aquifers here are affected almost immediately, to where if the depth of construction goes to any particular level in order, because of the foundation that you have to form, et cetera, because a lot of it is underground, that the interference with existing aquifers could jeopardize anyone within a mile's radius.
Okay, good. Other comments from the stakeholder advisory group as to what might help us determine which of these two facilities might be better for TOR, whether it be the Lake Oswego plant or the Joint Water Commission. Mike?
Larger plant might give people a better idea for odors and sound.
Okay. Good. Anything else with this table? Curiosities? Yes, sir. Mike? You have another?
I was just going to say the Lake Oswego plant might be beneficial because they do have they had a good neighbor agreement. It was fairly contentious. It was a residential neighborhood, and one of the big issues there was truck traffic associated with construction.
Okay.
So maybe not a visit to the plant, but maybe some of the people that were part of that good neighbor agreement, get their feedback if they'd be willing to share their experience during that project.
So not the physical plant itself, but the means of getting to the conclusions would be curious to learn. Okay, that's very good. Anything else up here front here? Okay. Chemical storage, right? Okay. So, yeah, that would be good. So chemical storage and application. We'll get a little bit into that, won't we, as part of your presentation, Jude?
No,
Not-
we had hoped to cover that as part of the tours themselves, so absolutely, absolutely, yep.
Excellent. Okay, that's good. Bonita, is this leaning to one or the other? Is it leaning more towards this one?
Yeah, I feel like probably the Joint Water Commission is probably going to be the direction that people are leaning toward. We can always bring folks in, as Mike had suggested,
Right.
from the other facility.
Gotcha. Okay, good. Yes?
Sorry, you've got part of the design team here to speak about Lake Oswego in terms of that
Yeah.
process and the neighbors and the good neighbor policy and all of that. So.
Good. Okay, with that, I think we've come to a little bit of conclusion. Bina, do you have any other questions about details, about logistics, or can we?
No, I think I'll reach out to the site advisory group members individually and get some input on timing, and we will open it up to anybody else that wants to be involved. Anybody from the community can come out and join us on the tour.
Great. Okay. All right, with that, I'm going to turn over the slide projector and the microphone to our cadre of experts here. And they're going to go through a series of slides to give a lot more data and detail about what to expect during design. Who starts?
I do.
All right, let me move this out of the way.
Good evening. Again, my name is Jude Grounds. I've met most of you in this room a few months back, and then saw a few of you again as part of the water treatment plant tour. I'm the design manager for the water treatment plant design team, and am here and excited to be here to continue to engage you all and get input and learn to empathize with what's the most important to you all as we start to move through this design process. Mark already introduced himself, but I'm happy to be here with Mark Graham. He's our project manager. Mark and I just wanted to share with you a little bit about, last time I was here we talked about the water treatment process and how the water flows and where the chemicals are added. Is it smelly? Does it make noise? Is it a bunch of lights? That was kind of our focus. And today what we'd like to do is provide kind of a 101 of the actual design process. Mark?
Sure. So I think you've seen this slide before. It's the overall process schedule, the project schedule, and how the project moves from pre-planning to planning into design and then on to construction and operation, startup and operation. We're really here today to focus on the design process. So as project manager, one of my key roles in this project is to make sure the project gets done on schedule. So we have a very structured process to go through the steps needed to get to the design. And we're going to talk about how that design process works for this particular project.
And as before, we hope to focus on the things that we've heard from you in the past, things that are of big concern for you. Last time you asked me some questions and I said, we're not quite far enough along in this design process to answer those questions, like how many truck trips, how many pounds of solids are produced by this process, and we're still not at that point. But what I hope to do today with Mark's help is to identify when we will be able to answer those questions for you, so you can kind of see how those decisions evolve.
And as we work through the process of this design, we know that the farther along we get in the process, the more difficult it is going to be to influence the overall design project. So we've been through the pre-planning and planning processes, and we've started to make some of these decisions, but there are still a lot of decisions that have to be made to get to the final end product. And as we start the preliminary design and design process, we're going to start down that steep curve of making these decisions and putting some of these decisions eventually literally into cement. But for now, we're putting them onto paper and getting these design documents put together. So the general design process that we work through is both linear and iterative. We always start with defining the project goals. Dave talked about some of the overall project goals that we established at the start of the project in terms of the values that we bring to protecting the waters, protecting the community, protecting the environment. And at that point, the Water Bureau did go out and get feedback from the community at large on what are the goals for the Portland's Water Bureau's water supply. We then work to identify the constraints. What are the legal, regulatory, environmental, geotechnical, all of these constraints, the community constraints that will influence the overall design. And then we move into the development of alternatives and then reviewing the alternatives, taking community feedback as we review the alternatives and iterating through that process. And if necessary, coming back and identifying additional constraints on the design process with community feedback. And ultimately, iterating through that process, we end up with a selected alternative. So this is a very generic design process that works on the big scale with the overall project, and that we walk through on the small scale, even on smaller decisions and medium-sized decisions. We'll talk a little bit about how we will work through this process for one of the major decisions on this project, which is what does the site layout look like for this facility.
And the filtration facility design process is really made up of two primary pieces: preliminary design, which we're just kicking off and will last about a year, as you saw in that schedule, and then detailed design. And below each one of these bars you see in light blue the deliverables that are developed as part of this. So first, there's the pilot study work that's ongoing right now, and we'll talk in detail about that. And then the basis of design report, and then incremental design developments as the design evolves. Ultimately, ending with 100% design documents. And we're going to talk about each one of these phases and a little bit about what we're doing kind of behind the scenes to make decisions, when and how we can solicit input from you all, and again, when we can answer your questions that you've been asking that we just don't have the information to answer today. The first phase I mentioned is the pilot study. The pilot's been up and running now for about 6 months. Pilot scale water treatment is really just a physical model of what the water treatment process is going to look like, with lots of dials to turn and bells and whistles so that you can figure out exactly the most optimum and efficient way to treat this water moving forward at the full scale. These are a couple pictures of the pilot scale. It's literally located in these two blue containers with a safety shower in the middle. But if you open the door and peek inside, you'll see things like, for example, these are pilot filter columns. These are 6-inch diameter filter columns that act just like the larger filters that will be built at the full-scale treatment plant. And what will the pipe... Pardon me? We do have chemicals and things out there, so we want to protect the operator's health and whatnot. So yeah, if something happened, they'd have something there to wash their eyes or whatnot.
Where are those located?
Location, up at the, inside the Bull Run watershed. Okay, so the types of things that we're going to be able to develop and determine as part of the pilot study is the water treatment process. We talked a lot about the different treatment processes, but there's all kinds of nuances with those. So we're going to really be able to iron out exactly what this treatment process is going to look like and demonstrate that it can treat water throughout a full year. And also, we're going to select the chemicals that we're going to be using at the full scale so that we can then understand the chemical doses, which equates to how many truck trips of those chemicals, as well as how many solids those chemicals produce and the solids that we remove from the water. So how many truck trips of mud we're going to be hauling off this site.
If you were using UV and or ozone, like any other major cities on the West Coast, how many truckloads of crap would we have to haul out?
Ozone requires typically a couple things. Liquid oxygen that you would truck up and fill liquid oxygen tanks. And typically there's another chemical, reducing agent, that we use at the tail end of ozone to make sure that there's no ozone that leaves the ozone facility, because we don't want to release that stuff.
How does that compare to the pile of stuff you're going to haul out with the evidently selected process that we're going with that costs so much more than like a UV and ozone?
How does the truck traffic associated with ozone versus conventional treatment? Conventional treatment has additional chemicals, and we talked about this last time, so I won't go into full detail, but I think that video is up. But there's coagulation chemistry, or coagulation chemicals, typically alum. There's polymers that get used, typically during filtration. There may be ozone associated with this plant as well. There are chlorine, bleach typically, and then there's corrosion control chemicals, just like the chemicals that are currently being used or designed to be used for corrosion control on the Portland water right now.
You say polymer, but that's kind of a vague term for, could be all kinds of stuff. Could you unravel out a little more for us?
Yeah. Polymers are typically long chain organic molecules that have a charge at one end and help us entrap all of the organics and all of the particles that are in the water and help them settle out so that we can remove them, and including pathogens.
Polymers have like other names for these things?
Yeah, for those of us with a chemistry background, can you give us the names?
There's a whole slew of different polymers that are out there. We could, if you'd like, we could maybe provide a list of the types of polymers that other water treatment plants are using in the area, and then you could kind of dig into those and see. We could also provide maybe the dosages that they typically use on a per million gallon basis or something, so you can kind of translate that in your mind to something that means something to you. Pardon me?
Most get removed.
Right. These are chemicals that get added and then we remove through the treatment process.
I mean, my husband eats most of his dinner, but what he doesn't is go in the garbage. Right? So what the water filtration doesn't use, it's going to be going in the garbage, which is a landfill.
Yeah, so the residuals was the question. Are there residuals? The analogy was used. My husband eats most of what's on his plate, but then there's some that gets stuck in the compost bin or stuck in the landfill. For that analogy at a water treatment plant is basically we use all of the chemicals. They cost money, so we don't want to waste any. But we ultimately remove them, and they turn into what you all saw. It kind of looks and feels like mud from a river bottom, and that's the leftovers that do get hauled away and land applied.
So landfill cost.
Mm-hmm. Yeah, and our industry, all of us, are working hard to find beneficial uses for that, and there are some progress in that area. The Water Bureau has very high standards in terms of sustainability, and so I know that they'll be pushing the envelope there, but here, we haven't found ways. For example, many of you are farmers. We haven't found a way to take that and turn it into something that you can use for fertilizer or something, because it's just inert. There's just nothing in there that provides any food. Pardon me?
No, thank you.
Right.
It's not something your kids would play in, right?
The
Like your personal kids, you wouldn't let them play in that mud, right?
No, I mean, we typically apply it to a landfill. That's correct.
But I'm saying that there's residual carcinogenic material in there.
No. There,
No carcinogen.
these materials are tested, and in order to actually apply them, they have to be screened. All the materials that come in are NSF 61 approved by, for use in drinking water. So they're all like higher than food grade, tested for health and safety of the chemicals that we apply into the water treatment process. We aren't putting carcinogens into our water treatment. Now downstream, yes, there are chemicals that get formed, the trihalomethanes, all your disinfection byproducts that are formed that we try and reduce, and we're able to reduce the formation of those chemicals through the removal of organic carbons or reactive compounds that react with the chlorine that we add. So this project, by removing some of the organic compounds, will actually reduce the formation of hazardous chemicals within the distribution system. So these are, anything that gets added by law has to be cannot have bad health effects. And those are the same things that get put in the water and then taken out. So what comes out of the treatment process in that sludge is the organic matter, the particles, the inert organic matter that was in the water to begin with, which otherwise would go into the distribution system and would have to be flushed out later on. Right now, the fact that we don't take it out means it's in the distribution system. It causes pipeline corrosion issues and sediments in the pipeline and requires flushing out of the pipeline. But anything that goes in, but we're able to take those materials out at the treatment plant, and then they get sent off to the landfill. So any chemicals that are introduced are removed for the most part, other than the chlorine that we add so that it stays in the water, the ammonia that we add to maintain a longer chloramine residual, a better chlorine disinfectant product in the distribution system. I mean, it's hard to say that there's no harmful waste on anything ever, but the chemicals that are added are very high grade and have no health effects. They get processed. Do other things get formed during the process? There's been a lot of research that looks into this. It hasn't been identified as a potential human carcinogen that's coming out of the water treatment plant process, Right, and those are what happens in the distribution system. Those disinfection byproducts are formed when you add chlorine and organic matter. By putting the treatment process plant in and removing the organic matter through a filtration plant, we are reducing the amount of disinfection byproducts, the potential human carcinogens, your haloacetic acids, your trihalomethanes. Those are expected to be reduced significantly as a result of building a filtration plant versus some of the other options.
Mark,
so anyway, we're getting into the weeds here a little bit, perhaps.
Yeah, agreed.
So.
But as I understand it, you don't add the chlorine in the other chemical at this particular plant. You add it at the Lusted Hills site.
Well, ultimately, the Lusted Hills site will go away. So this plant will take on the function of both the chlorine disinfection up at the headworks and the ammoniation, adding the ammonia, and the corrosion control treatment that happens at the Lusted Hill site.
So what's the evacuation reach if there were a chemical incident at the plant site? Chlorine especially.
That's one of the details that we were going to work through, and we'll talk about where that decision gets made. The evacuation up at the headworks right now is due to the presence of gaseous chlorine. So that's the chemical form of chlorine that's used up at the headworks for disinfection. At this facility, I don't, Dave, do you want to, we have a decision been made on the type of chlorine. It's not going to be gaseous chlorine at this facility. So there will be no gas chlorine at this facility, which doesn't mean there's no risk. There will be some form of hypochlorite, a liquid chlorine, either bleach or an on-site generated chlorine. It may be still on the table, so that there will be a much less public hazard material chemical used for disinfection at the new facility.
And how frequently will they be testing for procedure process and such to avoid issues? Requirements by EPA as far as safety, training, so on.
Sure. A lot of those are driven not by EPA but by the local fire code, since the fire departments have jurisdiction over the chemical safety. It's really not a public health as much as it is as an occupational and industrial health. situation. And so in terms of the specific procedures, we have, 3-inch thick manuals on chemical safety procedures at these plants. And so what the specifics are, without getting into, what the question on a specific chemical or specific process.
My thought process being the location of this plant is within probably, 4 or 5 football fields, probably less,
Yeah.
of a public school,
Okay.
Oregon Trail Public School.
Okay.
Grade school.
That's a great constraint that we need to have identified and think about when we think about process safety. So that'd be exactly a great reason not to put gas chlorine at this facility, which has already been decided, so it's kind of a moot point. But to also think about what the prevailing winds are and how we can enhance chemical safety so that we are using chemicals that do not have a risk of vapor release that could cause effects outside of the facility. I think right now everything is planned as liquid chemicals. It could be a constraint that could be added to this project to say, look, we're not comfortable with the risks associated with any chemical gases. And when you have chlorine, you could have ammonia gas. It's liquid ammonia is used at Lusted Hill right now. So a great input that, look, no gas chemicals at this facility, keep with the liquid ammonia. There are risks of off-gassing for some of the other facilities. Make sure that other chemicals, let's stay away from anything that would have a significant off-gassing potential and really focus on maintaining any potential spills on site with no gas releases.
Example, when you get through with your presentation, we're going to give the stakeholder advisory group the chance to write down items that are of concern or challenge, and actually physically place them on our map. Right. That's an exact example of one of the items, and I captured it here. So great. Keep going, Jude.
Thanks, Dan.
Mark, you knew that already, that there's a grade school close to this facility, right?
Oh, I didn't. I've only been on this project a few months, so this is I'm learning about the project.
Project manager should have known that.
I'm sorry, ma'am. We're here to learn about these these projects, and I'm here to get the input. So I'd love to hear anything more about things I should have known, because obviously I don't.
Three schools.
Three schools within
Yeah.
3.
If you count the 2 Orient
On that
schools.
map.
Yeah.
The two which kind of schools?
There's the Orient Grade School, the Orient Middle School, and the Cottrell School that is now an international something or other, but it was known as Cottrell School and is on Cottrell
Okay.
Road, and that's the road that leads to one of the roads that leads to your site.
Okay. Thank you.
Thank you.
Did I understand you correctly that the Lusted facility that sits astride or adjacent to the water main itself is going to go away and solve that?
Yes.
Dan?
My wife says since I retired as a policeman, I have to be less pugnacious in confrontation. I'm going to work on that.
Okay.
In what universe does it make sense to condemn a site that's already there instead of expanding it and then lay a mile of pipe that we forgot to include to our cost estimates to the city council, a half mile each way? In what universe does that make financial sense?
Dave, Benita, do you want to take that one? Because those are decisions that are, passed.
Well, I've been in the government for 27 years, so I kind of know how some of these decisions get made. But, and I'm not going to say that I know how this one got made. It just doesn't make any sense when the government has the power to condemn land, and I apologize anybody here for adjacent to that facility, to expand that facility instead of jacking one up half a mile or so away and running pipes through God knows how many people's property. I'm not directly offended. I'm on a corner at the end of the road. I'm not the police about it. But if someone was in the private sector doing this, they'd lose their job. The boss would go, what the hell are you thinking?
So we did look at the Lusted Hill site. I mean, that was an option that was considered for the reasons you're describing. There's a number of reasons why that didn't work. One is it's too small for the facilities that we need to do. It wasn't so easy to solve because of the zoning and land use requirements for the properties up in that area. It was made it more difficult, and to go there, we would have to purchase more property, gain more property in that area because we don't have the smaller area, and we And the Carpenter Lane property is one that we bought in 1975 for water system purposes. So, I mean, those were all things that were thought about and part of the siting evaluation that's available online, if you want to look at it in more detail.
Can I just ask you one quick question? Reflecting in terms of what's built, is that facility or the site that you currently have right now there, is it too small for UV ozone?
We haven't looked at that site specifically for UV ozone. That's why I'm hesitating in terms of thinking through what that evaluation might look like. When we evaluated UV, we actually looked at UV up at Headworks. And that if UV was being done, it would be done up in that location.
That's a great idea.
That's a perfect idea.
Yeah.
Jude
It
and
doesn't-
Mark, let's keep going.
Okay.
We're going to get to some of these
Great.
questions, I'm sure, as part of the conversation.
So as we move through the design process, especially during preliminary design, one of the key decisions or ideas we're going to explore is how we lay out the site. So I've got a couple of examples of where we ended up at the end of the preliminary design process for the Green River filtration facility, a facility that's similar to what we're proposing here up in Tacoma. Looking at two very different site layouts, but that both fit within the same constraints. Both of these layouts had all of the same facilities. They were arranged a little bit differently. They both avoided the wetlands that were there on site and stayed within the property boundaries that are kind of washed out just because of the way the slides are projected. So as we walk through the process of doing a site layout for this project, just like the design process we showed in the generic format before, we're going to identify what the constraints are, where our environmental exclusion zones are. We're going to identify our goals, what our building footprint sizes are, what we need to put on the site. And we're going to end up with a couple of options to evaluate, 2 or 3 options for the Carpenter Lane site that will fit all of the facilities that we need and that we can then continue to have conversations and optimize as we move forward in the process.
Mark,
Yes, ma'am.
the Green River site.
Yes.
It's on 25 to 30 acres.
Yeah, I think that's what it was. I think it was 30 acres.
It's at the headwaters of the Green River project where it does have a smaller dam size than the Bull Run project, correct?
Yeah, it's just a small diversion dam. It's not a storage dam behind it at the diversion to the Green River filtration facility. Behind that, up higher, there is a storage dam that's operated by the U.S. Army Corps of Engineers.
And it is also gravity fed, 42 to 46 miles to the city of Tacoma.
Yeah, that sounds about right.
Okay.
I feel like I'm getting cross-examined.
Clarifying that
Yeah.
somebody who has worked on a project that was at the headwaters
Yes.
and did not require 96 acres, it required 25 to 30 acres, and was completed in a 2-year period of time at a $30 million savings when the original budget was $250 million.
There are definitely some differences to that project because this was an existing ozone plant that wasn't meeting the city's needs. And so that ozone plant that had chemical facilities, operation facilities, all of the infrastructure for operations and maintenance. So it was an expansion of an existing facility.
You had to build around an existing working system
Yep.
in order to install it, and there was no break-in service to
Nope.
the city of Tacoma.
That's correct.
Okay.
Can you use a microphone? We can't hear you. We don't hear the questions.
Okay.
Do you mind?
That's okay. I was repeating my knowledge of the Green River project, of which Mark was one of the contractors or the managers of the contractors for that project. That project exists at the headwaters of the Green River. There is a dam further upstream, as he implied or spoke of. There is also a little bit of watershed. They had to deal with the U.S. Department of Wildlife because of the fish ladders.
Yep.
Similar to the Bull Run headwaters. It exists on 25 to 30 acres and provides 150 million gallons per day to the city of Tacoma, gravity-fed 42 to 46 miles away.
So as we go through and we look at the site layout, one of the tools that we can use, would you click ahead? Oh, you already did. Oh, there it is, are some of the 3D modeling techniques that we can use to look at various options. This is an example of a model we built for a new water treatment plant that we studied at Eugene, Oregon, where we looked at, we're able to rapidly visualize changes to the site layout, look at building sizes, building heights, play with the grading, think about the light and noise mitigation strategies that we would use at the plant, explore landscaping concepts, and look at some of the architectural style options using these design tools to communicate with the stakeholders, whether they're operators or community members or even regulators who are interested in the project.
The results of the preliminary design are typically the basis of design report, which memorializes all the discussions and decisions that were made, all the answers to all the questions that we can answer at that time. It includes preliminary site layouts, often some visualizations. Mark mentioned the plant for Eugene Water and Electric Board. This was a visualization that we used so people could see as they drive by I-5, what does this plant look like as it's perched up on the hill? We took that from a lot of different angles. And we mentioned Lake Oswego Tigard plant earlier. This was one of the building elevations so that people could see kind of the look and the feel and the architectural style of the buildings that were going to be installed as part of that water treatment plant.
What's the architectural style of the chemical storage facilities? Do they just look like a big chemical drum sitting there like everything?
No. Yeah, typically we put a lot of our chemical facilities indoors. Certainly at this plant, our chemical facilities are going to be located indoors in double containment with good separation and ventilation and all those kinds of things. So the architectural style of the chemical building often looks and feels a lot like the architectural style that's selected for all the other facilities. And Jeff is going to speak a little bit later. Maybe you could ask him directly that question at that time. Okay.
Yeah, so as we move through out of pre-design and get into detailed design, then we really start putting flesh on the skeleton that was established during the preliminary design process. So we start to refine the site layout, the circulation, the locations of the buildings. So the two site layouts that I showed before, this is a 3D visualization fly-through of the plant that we put together based on the 60% drawings, using the 3D models that we had developed to interactively decide on the site layout to give an idea of what the overall facility is going to look like. So like Jane mentioned, this is about a 30-acre site, very similarly sized facilities that to what we would have up at the Carpenter Lane facility. So we will continue the detailed design with selection of equipment, design of some of the interior spaces, the architectural design, our landscaping design. We can do lighting simulations that will show what the impacts would be to the community, identify what sort of visual and auditory screening will be effective at the site. And then we can start looking in detail at the traffic impact analysis, both for the construction phase of the project and the ongoing operations and maintenance of the facility, and evaluate the effectiveness of our environmental mitigation measures.
Can you expand on the dark sky compliance there? Is it totally dark at night? No light pollution?
No, the dark sky is Jeff, I don't know if you want to describe what the rules and regulations and the initiatives to maintain the dark sky is. Okay, he'll have it up. But no, it isn't going to be an invisible site. If you fly over the site at night, you will see this facility. Floodlights are actually not allowed in general, except for emergency security and maintenance. So this is an area of real concern, and a lot of design effort goes into minimizing it. But we can't promise that you won't know the facility is there at night. It will. It is a large facility that you will have some impact on the sky. But we design our best to mitigate that.
Kind of the next step is detailed design. This is when we really, this is when we really start thinking about the construction and the long-term operations of the plant. We do a lot of
taking of these 3D models that have evolved, and then we turn them into models that actually help us understand how these things are going to be constructed so that we can understand the health and safety implications of everything. This little video here shows you a filtration facility that was constructed recently in Sacramento. And it's just a time sequence of when things are going to get built to make sure we don't have contractors, working over the top of one another and whatnot. Typically, we understand from these types of things the types of construction constraints, the sequence, ultimately the construction schedule, to help give clarity on that to you all. We can better control and have a better understanding of the construction impact, like traffic, dust, noise, what are we going to do with stormwater, those types of things, and ultimately the definitions of the long-term kind of maintenance and operations of these facilities.
I think it's yours, Jude.
And the punchline to all of this is the engineering contract documents, which I think for this plant will be something like 1,500 drawings and probably about 4,000 pages of specifications that articulate exactly the vision that we've come up with, and we hand that over to a contractor. This project, we're fortunate enough to be delivering through a methodology where the contractor is actually going to be on board working with us all through design so that they understand what's going on and what the constraints are out on the site, and also how do we design this system to make it more safe both during construction and long-term operations. We use various submittals to get things like land use permit. Typically, we submit for land use permit with about 60% design, kind of conceptual design, where the building heights are locked down, the architectural features are locked down, and then ultimately with 100% design, we go and get the building permits.
So this is an overview of just one portion of the project schedule, the detailed design that Jude and I are very excited to be working on, and working with the Water Bureau and with the community to develop a great project for the long-term protection of the Bull Run water supply. I think, what's our next slide? And do you want to?
Just again, I hope that we were able to help you understand when we can answer these questions and when we're going to have, the details. If you have questions, and even though we don't have specific answers now, if we can find creative ways to find analogous situations in the community now and share that with you so you can start kind of understanding what those impacts are, we're all for it. Let's just continue talking and we'll do what we can.
What's the noisiest thing that might happen during construction? Driving piles, digging. Look, you've been around enough of these projects.
Sure.
So what's the most disturbing thing that we would expect?
I mean, pile driving is usually the worst thing for any community on construction. So if the recommendation is to use driven piles, that would probably be the loudest thing that you would have. There are other options other than pile driving, so that's something that we would definitely look at. And as we look at construction, I think pile driving would probably be very low on our list of construction techniques. Dynamic compaction of soils, where you haul up this big weight and then drop it in order to compact the soils, is a pretty loud thing. You've got at the Green River facility, we used stone columns where we rammed a bunch of rocks down in there to create columns. There's lots of noisy stuff that goes on at these construction projects. We will be working with the CMGC, the contractor on board that comes on, at about the time we get to pre-design, to identify better ways of doing these things. To use drilled piles where you have an auger and then you fill that with concrete or steel to create your piles. A lot of it is just all that earthwork, digging it out. You got the backhoes, you got the backup alarms. It's not a pretty sight.
It's going to be very, very uncomfortable for those of us that live nearby, right?
Yeah.
It's going to be pretty brutal.
It.
Want to live right next door to that activity? I mean, you know what it's going to be like, pretty much. So, what would that be like for you and your family?
And it would be a difficult thing to live through. I'm not going to say it's going to be cake and roses. We want to understand what we can do to do some of these things early. Perhaps we can build berms around the site early on so that we can, so that you won't hear or see the activity going on behind that berm. There are things that can be built there.
to be this project.
Mm-hmm.
It's going to be insane, man. You're going to shake my house with this construction project.
They'll have complimentary earplugs.
Well, I feel like that's what's being missed here. You're sort of glossing over what this community is concerned about with a SAG process that you're not going to ask these people to vote on anything of any meaning. You're ruining our community. The community of Pleasant Home is going to be wiped out by this project. I would say without question during the 5 years that it's being constructed, and I think longer than that. But this is a massive impact on us, and it's like we're churching this thing up or something to this group, and we're all supposed to be okay because we get to participate in this question and answers. This is crazy for us. I don't think you guys appreciate the extent to which this impacts us in our lives. There's just no way. Or you would have proposed to do something like you suggested, David, up at Headworks or somewhere where you're not. There's a level of disregard for our community that, as you can see, is really concerning.
That's right.
It's $1 billion project. You just wiped us out. What about what I put in to own that house where I live? You can't find me another house like that. This isn't just a neighborhood with cookie cutter homes. These are all custom homes. A lot of them have been handed down over generations. Find another way. Find another solution. You've got $1 billion you want to work with. And this is the best you can do, is to wipe us out. You've got other options for this. Much cheaper options too. I get that you want to do this thing. I don't fault you for that. Y'all are nice people. You got a job to do. Dang it.
And the concern I have is, what's my property value going to do? I mean, already, I just did a $250,000 remodel. What should I have done? Moved instead? Perhaps, but would I ever have a backyard at the Sandy River again? No. It affects more than just the people right on that road. It affects me a mile away. And how far out does that ripple go as far as property values? How far down are my property values going to go and everybody else around me while this is happening? And then at the end, I mean, what happened in Lake Oswego? Does anybody talk about that? Does anybody know?
Let me interject here for a quick minute. And that is this working? Can you hear me? Thank you. We're so glad we could hear that. The reason why Bonita and Dave is really structuring this is to allow for these conversations to take place. So very much appreciate it. We're glad that you're here. We're glad that you're sharing your thoughts and concerns. Part of our responsibility with Dave's direction and Bonita's help is to ensure that the language that you just shared with us is transmitted to their decision makers, Commissioner Fritz and the City Council. Okay? They are the ones that make the conclusions.
They take the recommendation. I've been to those hearings. I've testified there. David Peters sits there and says, this is our recommendation, and the council goes, okay. So don't spin it like somehow I got to go deal with the city council. They're looking to their bureau to make these calls. So here's the bureau. I'm talking to you guys now saying, do this somewhere else. In fact, do a much cheaper, less expensive, less impactful project. Everybody wins. But don't do this on top of our community. Come on.
Understood.
Yeah, so why
Understood.
don't you step in, let these guys answer the questions? Just
That's great. If we can answer the questions relative to, in fact, the next portion, it might be very helpful. Jeff's going to give a little more conversation about lighting and noise, which I heard is one of the comments that you had. Would that be fair? Would we allow Jeff to give a little more insight on that? Does that make sense? Is that the next portion?
I got a question. My biggest, I've been asking all along where we're at with this thing. If you could give us some target points for the preliminaries, the traffic studies, some of the things that we need. I'm probably the closest one to this project. I'm maybe 60 feet away. And all I want to know is the traffic, how are you going to access the site? And I know I've been in construction dang near 50 years. And I know you know more than we're telling us. But every time we ask, you say, we don't know. I want to know the target. I bid plants at 20%, 50%, 60, 75. You know, I know you know more than you're telling us. But we need to know. My wife and I we don't know if we want to live here anymore. But tell me where the roads accesses are. Tell me how it's gonna range. I know how you're doing with the plants and how you can manipulate them and stuff. And I know you've already done a bunch of that, you know. But tell us. We're getting real tired of saying, I don't know.
Sure.
Perhaps there's something we could do. The Green River plant, it's a pretty analogous plant in terms of capacity, in terms of concrete, excavation potentially. It did have some other facilities that were there already, so it would be a little bit different, but maybe we can share some of the numbers from that, and that might help kind of paint a picture of what this might look like.
It's too small.
No.
It did not have a neighborhood.
No, they did not have a
It was,
neighborhood.
right, way away.
Right. But in terms of truck traffic and what those quantities we have for that plant.
But when you're throwing things out at us, let's look at a $160 million plant. Million gallon plant. Don't show us a $45 million gallon. That doesn't do us any good.
Right.
You tell me the quantities of chemicals at a 45. Well, we're 160. That's 3 times the volume. Talk to us like that, so we know. Is it 1 truckload, or is it 15 truckloads of chemicals? That's what we want to know.
Yep. Thank you for that. Understood. And again, I think we can look at chemical deliveries at Green River and get some, not just estimates, but some real truck delivery and construction traffic from that project that you all can kind of take and use as a starting point for understanding the impact.
Yeah, and we can provide some scaling factors to say, okay, this facility was 80% of the capacity that we're going to use here, so it's not I think that you provide that context that when we are showing you examples, making sure we also communicate the the scaling factor that's going to scale up. That if it is a 10 MGD facility, obviously that there may be some element of that is important, but it's the wrong scale. The hazards of the chemicals, talking about chemical hazards, are the same for particular chemicals, but obviously the scale is far different at the different facilities. So I think Dave, we can put together information that will answer to the best of our ability at this time. It may be a known range. Now that we're coming on board as the design team, we'll be able to put some pencil to paper and provide preliminary information on some of the most critical questions that you guys have. And in terms of roadway in and out, how that works, I think we have some maps up here. This exercise that we're going to be doing here in a little bit, we can have some conversations about what are the sensitive receptors, what is along in this area, what your thoughts on the best way as a contractor to get materials in and out of this site to minimize impacts to the community, if that's something that you thought about, that you could share with us and provide some guidance to the design team as we start looking at options.
The facility of those plants here, the Green River plant and when you're modeling in Eugene, are those the same situation? Are those also big massive filtration plants that are going to have all the same waste?
So the Green River Filtration Facility is in operation. It's been in operation for 5 years. So that's very similar. That's 150 million gallons per day versus this 145 million gallons per day. Very similar water quality, very low turbidity, previously unfiltered water supply. Tacoma made the same decision that the Water Bureau is making to build a filtration plant for a lot of the same reasons that Portland has laid out. So they're getting the similar chemicals. They're hauling off a similar amount quantities of solids.
solids. At that plant, for example, in the summer, they don't haul off solids at all because they aren't generating enough to develop enough to haul off. Just because the water is clean and they're able to store it on site for for a few months. But then when it comes into winter, they're hauling off a truck every few days of solids. They're getting chemical trucks in every day during the high usage season in the summer when they're treating the water, treating more water. And we can talk about all of the traffic that goes in there. It's a very different situation, though, of course. I mean, they're logging up there during the summer, so there are logging trucks going up and down the same road shared with the chemical trucks, all day. So it's a very no. But in terms of comparison for chemical loads, if you're talking about in a community, the Lake Oswego plant, and talking to those neighbors about how that worked with 60 feet away, the water treatment plant was being built, right there beside them, and how that whole process worked together. Every community is unique. There's no exact replica, so we can pick here and here. This is the same capacity. This had similar community impacts. This had a similar treatment process, and hopefully, we can communicate where each element has been done before and get some ideas of impacts, mitigation measures, how the process works, so that you can get a composite image of what the impacts of this construction and operation might be to your community.
What sort of plant is the Eugene plant?
Well, that one we didn't get past preliminary design on that project. Eugene has an existing treatment plant. This was going to be a redundant plant to improve resiliency and reliability. They're still wrestling with the options for them. It's a different water supply. It would be on this one we were looking at was on the Willamette River. Much lower quality water. Definitely had to be a filtration plant with full sedimentation.
I have a question that's maybe kind of off this topic, but I think at one point during some of the previous conversations, the reason you're not doing the headwaters is because of seismic concerns and earthquakes and that sort of thing. Was that part of it?
No, there are fewer seismic concerns up in the headwaters.
Yes.
It's the size of the facility just won't fit up at the headworks. If you've ever been on a tour up in the Bull Run watershed, it's a very narrow canyon that's all rock, and there's just not enough property. We've talked in the past that we're thinking this facility is going to be in a 40-acre range. There's just not that type of flat area up in the air.
I realize that this is a flat area, but it's also a flat area technically on the edge of a river valley. And when you look at the geology there, where the plant's going to be is at the top of the flat portion is on more or less the plateau. And then the grade drops down, and then below that is yet another flat area before it drops down to the river. What's the history of the geology there with soil movement? I mean, that's all.
Yep.
I mean, it can turn into it could all go down in the river.
Those are good questions, and those are all things that we're looking at during this design process. I know you've all noticed that we've had drill rigs out there. We've been drilling test holes and getting a feel for the geology out there. And so we will be able to bring that information and use that information to help us understand those questions.
Isn't that something to do before you start designing and make sure that the geology is safe?
We have been working on that, yes, and we'll be providing that information to the designers to take a look at that and see how it works with their design ideas.
Following up on your statement about the drilling, what can you tell us at this point about what you've discovered in terms of both the geology and also the groundwater on your site?
So I'm not the best person to ask that. Oh. No, there's other of our team members have been working on that element, so I don't have all the answers with me in terms of the details of that. But
Probably a lot of people here would be interested to find out, especially since groundwater is a big concern anytime you have a construction project.
yeah, I mean,
It'd be helpful to kind of maybe see
So we'll get that added to our list and come back with that information. So we'll be doing studies on the wildlife in that area also to better understand the impacts. Yeah, and that will be information that we'll take into account as our design. Definitely not, but we will be doing studies on that also to evaluate whether there are some taste differences, and that's all part of our design process that we'll be going through.
So the thought here is, Dave, that a lot of good comments have been coming up, and part of our exercise today is to ensure we're getting all these things. We want to write them down. We want to have them written in a way that that Mark and Jude and even Jeff and others can take these and make sure that we're incorporating them into the design process. So you can't see it, those of you in the back, but there's 2 photographs up front here on the floor, and it is the actual picture of the facility, the site, and then, of course, the contiguous area. So the idea is that we want to start placing, giving you in the time to write down a couple things and help us with some more information. For example, the idea about, hey, there's a couple schools here. Let's actually put them on the map so we know where they are, and that we have much more data to go on. So I'm going to give our stakeholder advisory group up front here little, what do you call these things, clipboards with some pens and some paper. And even Libby's going to be handing some of those things out also in the back of the room too, that we could actually capture these things. So let's actually kind of focus on getting that material put together here for the next roughly 10 minutes or so, and ensure that we're talking with the individuals here like Jude and Mark and Jeff and Dave and others, so we get this data in our heads, okay? So that's the intent for the next 10 minutes or so. Who would like to take the picture? Yeah. The whole thing. Sam's back there taking the entire webcam of this entire...
Are you going to write the stuff down so we know you got it? Because if we just write it on a piece of paper,
we want you to write on a piece of paper and bring it up front here and make sure we tape it on the right spot or have it as a general consumption. And between Libby and myself, we'll take a picture of it, we'll hang on to it, we'll make sure we keep it as part of our process. Okay, there we go. Let's start with that and see how far we get. Okay. Can I have your attention just for 30 seconds, please? We're going to officially break this meeting off. We think we're getting a lot of value out of these conversations up front here. We can have this room for another 25 minutes. We have to be out of here at about 8:15 or so. So please continue the conversations up front. Benita's going to connect with the stakeholder advisory group members to work out the logistics for the site visit in February, and we'll be back here in March. So thank you for coming. Keep the conversation coming up front. Thank you.